Hello and welcome to the first webinar of the 42 Crunch three-part series on the OWASP API Top 10. We're really excited about this series as we've brought together renowned expert Philippe de Ryck, founder of Pragmatic Web Security, and our own Colin Domoney to share with you their experience. We hope you'll enjoy the format of the series. It's a little bit innovative, and I'm Hugh Carroll, head of marketing here at 42 Crunch, and will be your host. So we put together the series and we designed it to take a deep dive into understanding and addressing the OWASP API security top 10 issues, but also to provide you with a step-by-step walkthrough of each of the challenges, how to identify problems, and most importantly, how to remediate them. So just before we kick off, I'd like to introduce our speakers. First off, we have Colin from 42 Crunch. Before joining the team, Colin worked in a variety of security roles with Veracode, Cyberproof, CA, but also with end-user enterprises such as leading financial institution Deutsche Bank. Colin heads up our developer advocacy initiatives here at 42 Crunch. He's also an API security researcher on our team, and in his spare time manages to edit one of the industry's leading weekly API security newsletters. Hopefully you're all familiar with it, and if not, I recommend you get a subscription straight after today's session. Our other speaker is Dr. Philippe de Ryck. Philippe, in his own words, helps developers protect companies through better web security. As the founder of Pragmatic Web Security, he travels the world to teach practitioners about the ins and outs of building secure software. He's also a published author, and he reliably assures me that it's still available on Amazon if you look hard. He's also worked with some of the largest companies on the planet. We're delighted to have him join us for today and the next two webinar events. So welcome, Philippe. Just a little bit about the format for today. So the first session today is very much a fireside chat, very conversational, very interactive. We're hoping to encourage everybody to submit questions. So, we're going to invite you to submit via the Q&A. So please feel free to do so. The focus for today will be very much kind of understanding the security landscape, understanding the differences between the traditional OWASP top 10, which many of you are probably familiar with, and the more specific API top 10. What are the key challenges? And indeed, we look at some case studies. And then obviously there are two remaining webinars in the series in February and March, and there'll be a much more fine-grained deep dive into each one of the 1 to 10 challenges, and Philippe will be walking through each one of those in an hour-long session for each. So be sure to make sure you're registered for those as well. You are automatically, but we'll remind you as we run up to those events next month and in March. Just before I hand over, thanks for your patience, some housekeeping rules. You are all muted. If you do wish to submit questions, we recommend the Q&A window because our speakers will be checking the Q&A window. So please use that as opposed to the chat window. It's better. The recording will be shared, made available within 48 hours on demand, and there will be a couple of polling questions. So in time-honored tradition, we like to encourage audience participation, and we're going to push one of those questions now. So question 1, what is the closest description of your current job title? We have out in front, security engineers, followed beyond the others, we've got enterprise architects, and then a mixture between front-end, back-end developer, API developer, and finally heads of security. So I'm going to stop sharing there, and I'm going to hand over to Colin, who's going to kick off. I'll stop sharing, and over to you, Colin.
Thanks very much, Hugh, and welcome to everybody joining, and particularly welcome to Philippe. Really good to have this conversation.
Yeah,
Philippe?
Absolutely. It's a pleasure. It's a pleasure to be here. And it's awesome to see so many people dropping in to the webinar and answering their other questions. I asked them in the chat, like, if you're other, what are you? Because it's awesome to see that scroll by as we go along.
No, for sure. So I think, there's probably not a lot of people that aren't familiar with you and with your name and the security industry. I've known your work for a long time. A question for you, most people, when I talk to them, kind of have stumbled into doing application security or software security. They've normally had another job. I come from a development background, and I sort of stumbled into security. You, one of the people that to me look like, you would deliberately wanted to do software security. given that you have a PhD in. How did that journey start? How did you get interested? What was that? Where does that interest come from? What's that journey look like?
My story. I get that question quite often, and people seem to expect like this answer, like, oh yeah, of course, that's why I'm doing security. And to be honest, I don't really have a good answer to that. It's something that kind of happens, and something that I never resisted either. I mean, it just rolled that way. So I started programming at not that young. I'm not like one of these kids that was at 6 years old hacking computers. But I was a bit older, and we started writing some small scripts and doing some fun stuff. And it kind of went well. Computers were my thing. So I went on to study computer science at university, as a lot of people do. And I kind of always had the security mindset of looking for loopholes, like even in daily life, if you go to the supermarket and they check your bag if you stole something, they check like one of the 3 compartments. I'm like, how does that work in practice? I mean, that's not very good security. And it kind of translated to software security. And at university, we could choose a major in our computer science master, and that was secure software for me because it made a lot of sense. It's basically going into depth into security, getting in touch with a couple of different areas. And then they asked me, like, would you like to do a PhD on security? Because we need good people. And this seems like a good match. And I was like, yeah, because I don't know what I want to do with my life. I probably should get a job, but I don't know which one specifically and where. And so I was like, yeah, sure. PhD sounds pretty cool. And I talked to a friend who was doing a PhD and was like, yeah, this is actually pretty awesome. And you get to do a lot of cool stuff. And well, let's be honest, you still live somewhat like a student, but you get paid in this case. So I started doing that, and pretty quickly it worked out really well. I had the advantage of having some good advisors who put me on a very technical assignment. Like I built a browser plugin against cross-site request forgery, which is basically what Chrome is doing right now with the same site cookies by default. That's what that plugin did. And it went from there, and that's how I rolled into it. So it's not like a deliberate plan when I was 16, like I want to be this in life. It's just like, we'll take it as it comes and we'll see where it takes us. And that's how I ended up here, I guess.
Cool, fantastic. And you still involved with academia, with the University of Leuven, the SecOps Dev? Just talk very quickly about that, and maybe where they can get to see you in person now that we're back doing in-person things.
So I kind of left academia behind me in a sense that I did my PhD, and then I was sick of the whole publishing papers, getting reviews, which are sometimes good, sometimes bad. I was like, yeah, I'm done with that. And I started doing workshops back when I was still at the university, workshops for developers about security. And that's how I rolled into my current job, where I basically teach developers about security day in, day out. So I'm not publishing anymore. Of course, I'm still in touch with a whole bunch of people that do. The university is like around the corner here. So I'm still in touch with people locally here as well. So absolutely. And then we do SecOps Dev, which is a week-long course here in Belgium, in Leuven.
Okay.
We used to do it every year. We were on a streak of 16 years in a row, and then some bad stuff happened all over the world. And now we're in shambles because, organizing a live course with people for a full week is not something easy these days.
Yep.
But yeah, usually you can find me. That's what you said in the intro, like Philippe travels the world. That's my bio. But you should be used to travel the world because I've been away twice in the last 2 years, which is not that great. But normally I'm at conferences speaking. I'm doing a lot of virtual conferences, webinars these days. But yeah, people will definitely be able to find me if they look for me.
Cool, fantastic. Right, let's start talking about API security. And I think the first question that I have around this is, how different is API security from web application security? I think you've got a background in, on the browser, on the single page app side. Behind you, you've got your Angular man. I know you contribute.
That's me. That's not the Angular man. That's me.
And you're still very involved in the Angular community, which is great. I come from the web app side, and how different is API security? Is API security actually a thing, or is it just an extension of what we already know about web application security?
That's a good question. I would say it depends on who you ask. So we obviously talked about this up front, and my answer is not going to surprise you, but we have different viewpoints on that, and that's actually quite interesting, because you said to me, like, yeah, for us API security is something completely new, and for me it's like, it seems like a new problem, but there's a lot of old stuff in there as well. And this is probably maybe a good time to start sharing some of the slides here. So let me set that up.
Sure, absolutely.
Right here. Let's do some screen sharing of my empty screen, and let's dive into the API security top 10. Wait, now I have to find you again. All right, so I can see you as well. Awesome. So that's the API security top 10. Now, this is not API security all there is, but this gives you a very solid idea of what's going on with API security, what the most common issues are, and whether you agree with this list or not. Data, real life data shows you that these issues are definitely there in a lot of APIs. And I have plenty of stories to tell about each of these vulnerabilities, as we will do in the next 2 sessions, basically. So if you look at this list, some of these things jump out at you. If you've been doing web security for a long time, you see like authorization, authentication, like, yeah, that's a big issue, but we kind of had that with traditional applications. So is that really new? And I would say, like, maybe not. We have things like aid injection. That's a shorthand for all kinds of injection crap we have today. Think about SQL injection, command injection, but also GraphQL injection or NoSQL injection, stuff like that. Not a new issue. It's a problem we've been having for 25 years, and it turns out we still have that problem in API. So my official answer is, I don't think the security landscape has changed significantly, because if you compare this to the traditional OWASP top 10, like the web application OWASP top 10, not the API security specific one, you'll see that a lot of these issues come back. Authorization, injection, authentication failures are in there. And if you put them together, I've done some mixing and matching of mapping the API security top 10 to the normal OWASP top 10, if you want to call it normal. And you can see that there's a whole bunch of things overlapping. And I don't think that has changed. And I think the security principles that we have been teaching for decades, whether we're succeeding in that or not, I'm going to leave that in the middle for now, still apply to APIs, absolutely. What we do see, and that's something where we do agree in the viewpoint, what we do see is that APIs are much more exposed. As in, if you had a problem in a traditional web application, you had your JSP or ASP.NET pages in front of it, and there was no direct connection to the backend processing requests, and maybe you get through to the front-end page and make the backend do something, and you can exploit a vulnerability. And in APIs, that definitely changes. In APIs, we now have direct access to the endpoints. We can manipulate the data that they accept. We, as attackers at least, we have much more control over how we approach an API. And I think that is a massive change in the security landscape. And that is why API security should be a separate category. I absolutely agree with splitting that off and focusing on these things, because we see this over and over and over again as people making mistakes against these principles. So, yeah. By the way, I don't give short answers to questions usually. It's always, always a bit of a story behind it.
So we'll come back to the one category that stands out to me that is new, and that's let's have a look at number 3 and number 6. Now, those are basically both data errors. Right? One is exposing too much data, and one is trusting too much input data. And obviously, APIs all being about data. You know, what's best practice? Do you get lots of questions on that topic? Because that's a new category of error.
Yeah, 3 and 6 are absolutely interesting, and they're the perfect illustration of what I just said, right? I mean, back in the day, you exposed your objects to your GSP page, you plucked a couple of fields, you dropped them in the HTML, and you send it back to the client, and all is good. Hopefully, if you've done your cross-site scripting protection and so on. And now it's like, oh yeah, you take this object, you throw it in, well, you don't do this manually, just throw it in a response, and your framework is likely gonna JSONify that if you're doing Python, or it's gonna use Jackson in Java to translate that into JSON and throw it to the client. And the principle is the same, like take an object, expose it, everybody happy. And then you get excessive data exposure, because now your object from your data layer, your services, whatever, contains potentially sensitive fields and they're being exposed in JSON, and you don't see that because your front end, your client is going to handle this data, be like, oh yeah, I need this field, it's going to display that, and everybody's happy. And your QA team is going to be happy because, hey, this works as expected, all is good. Until someone looks at that API response, looks at the actual data in there, and it's like, oh crap, why are these fields in there? There's cases where people are leaking location information from users, like, whoops, that information wasn't supposed to be shared. But it's there, it's just not used by the client, but very visible once you start inspecting API responses. So do I run into these issues often? Like, yes, I do. And we're going to talk about this in next month, in the next session. But fixing those issues is actually not that simple, because it seems like a simple problem, right? Like, oh, just don't expose a field. It's like, okay, but how do you do that? Like, oh, what if we go through all of our fields and add like annotations if you're doing Java, like, oh, this one should not be exposed and this one shouldn't. And that's a very hard problem to solve. And there's patterns you can use like DTOs to have data transfer objects and things like that. But it takes active effort. And yeah,
I'm wondering in a way if APIs aren't almost a victim of their own success, because we have this fantastic tooling. We've got object relational mappers that can, takes what 5 minutes to run up an API in .NET. And people kind of don't think about what's happening under the hood. Right? It's very easy mass assignments if you just expose the whole data object. That's how people fall victim to mass assignment, and that's exactly the same with data exposure. So you have that double-edged sword. You have all the advantage of this fantastic scaffolding and tooling, but that brings with it its own set of problems.
Yeah, absolutely. And I often dislike automatic tooling. It depends on the mood I'm in, I guess. If I'm trying to build something fast, then tooling is awesome. But if you're trying to understand how something works, if you try to look under the hood of these things, sometimes it takes like a lot of effort to figure out what the hell is going on, who's handling what checks are being done. And more often than not, I just end up writing a proof of concept, like, is Spring Security checking this claim of a JSON web token? Like, I don't know, I have to go build a proof of concept, try this out and see what they actually check. And sometimes it's yes, and sometimes it's no, and things like that. So yeah, absolutely. It's definitely a significant problem and a very invisible problem. And those are the ones, you can see that in the ranking, like injection, SQL injection dropped from 3 to 8 in the API security top 10, because SQL injection is usually kind of visible, and tools like static analysis is kind of good at finding them. And hopefully in the end, because in a couple of years, we'll be able to address injection altogether. But the other vulnerabilities like authorization problems, data exposure mass assignments, those are invisible. As in, if you look at a piece of code, there's no line of code that jumps out that says like, hey, this is insecure. There's something missing. There's something happening under the hood, somewhat invisible or not happening at all. And unless you know how to look for these things, you're probably not going to see them in a code review. It's unless you know to look for, is this endpoint enforcing authorization? You don't see that, because there's going to be something like, is user authenticated? Yes, go forward. Otherwise, we don't. But you also have to check object level authorization, function level authorization. And those things are very hard to do if you don't know how to look for them explicitly.
Yeah. So I wonder if we just here, if you could do us a favor and pop up the polling questions. So talking about those categories of issues, let's have a look what people said are the ones that the answers, please, here to the questions.
Yeah, let's have a look. Just before I go to the polling results, there's a couple of questions there in from the floor.
I'll deal with that in a second.
Okay, so let me see if I can share the...
Martin, to answer that question about APIs, I think we're going to be talking about both back-end APIs and APIs in SPA. Philippe has the expertise as the Angular and SPA, and the from front-end apps. But generally, we're talking about all things APIs. And Adrian will come to the question around tools. That's probably where we're going to go next.
So hopefully you can you see it on the screen there?
I can do. So the answer to question 2 was around which of those security vulnerabilities impacted you the most. And it's 39% authentication, authorization 26%, data issues 24%, and BOLA down at 11%. So authentication, quite a long way in the lead. I guess that's nothing not to be expected, Philippe.
Yeah, I actually talk a lot about authentication to customers, and at trainings, people always have questions about that. I have a full session on API authentication techniques where we go over all the different options, and yeah, people always have a bunch of questions. It's hard to predict, but it happens. Like in a one-day training, I blocked out like an hour to talk about API authentication, and people start asking questions, and we end up at 2.5, and I'm like, oh crap, what am I gonna skip for the rest of the day? But I'm happy with those questions, obviously, because it means that this is super relevant for people, and they deal with that quite a bit. But yeah, you'll have choices to make. There's authentication is a very solvable problem, but it's very hard to actually solve it in practice, because, and I start that session, and I've done public presentations at conferences about this same topic as well, and I started by saying, like, I'm going to give you a bunch of options and maybe some recommendations, but I can't solve this for you, because it all depends on how far you want to push things, how comfortable you are managing keys or secrets, and how flexible you want to be, and that makes this quite difficult. Absolutely. So honestly, it doesn't surprise me to see authentication issues there, because getting this right is really, really hard. And once you have authentication, then, to be honest, authorization is often not that difficult, because a lot of use cases are fairly straightforward. Of course, the moment you're in like a complex authorization scenario, then that's a whole different story. The moment you have like very complex rules on who's allowed to do what, when, that's a different story. But plenty of customers I talk to are mainly looking for a solution for handling authentication in the first place, and then piggybacking authorization on top of that is typically a bit less complicated, and there's somewhat less trade-offs to make once you've done the first part correctly.
Good. Do you think APIs are the new attack vector? I mean, we see, and I know you've got some case studies that we're going to in a second about, the type of mistakes that people are making and the breaches that we've had. Do you think that increasingly they're coming under attack, that people, because web application is a more mature and more well understood domain, that APIs are the new focus because they're carrying the highest valuable assets?
Yeah, probably. There's a bunch of reasons, actually. First of all, APIs are very popular these days. So that's one thing. I mean, go back 10 years and we also had APIs. Go back 20 years and we had web services, which are basically APIs just with some horror XML around them. But in essence, these APIs have always existed. But if you learn programming today, you're going to learn building APIs and either a native app as the client or a front-end application. And whether you like it or not, you're building APIs. And that means that there's a bunch more APIs. It means a lot of older systems are exposing their operations as APIs, often to third parties, which is an absolute nightmare to secure. So yeah, I wouldn't say APIs are a juicier target. It's just there's many more APIs. It's like, it's so easy to find an API with a vulnerability compared to a traditional web application just because of their prevalence. And that makes them an interesting target. And of course, once you find a massive vulnerability, because the API is more exposed, there is going to be more to exploit, and you might be able to pull out millions and millions of records, something we've seen with traditional applications as well. But yeah, with APIs, it might be easier, especially if you have a vulnerable and misconfigured API system in front of you.
Yeah, and of course, they lend themselves to automation and automated attacks. They're well documented, they're easily discoverable. So it's a bit of a perfect storm. Let's talk about testing, security testing. And this question comes up, and we've got a question here on around DAST. Do you think that the security tools that we've traditionally been using for web application testing, so the likes of SAST and DAST, how applicable, how well suited are these for API testing? And is there danger that people become too reliant on just repurposing what they already have?
Yeah. My first response would be, what do you want to achieve with your tools? I mean, if you're looking for a tool that can analyze your API for potential security issues, corresponding to the API security top 10, as we see here, then you're not going to be a very happy customer of a DAST tool, a dynamic or a SAS tool, static analysis tool. Dynamic analysis might be a bit better. DAST could catch a couple of these authorization failures. Depends a bit on how well it's accustomed to the system, its testing, and what it can do. I don't know all the DAST tools out there, so I can't speak of or recommend specific products. But the thing is, even if you have a tool that scans your APIs and maybe it can find authorization failures, sure, broken authentication should be possible, but excessive data exposure, like, how does the tool check that? It scans the API, it finds a response, it's like, oh yeah, there's 7 fields in here. Good. As long as one of the fields is not called password, it's probably not going to ring a bell whether that is sensitive data or not. Maybe it finds password. I don't know. I haven't tested that. But and that brings us to an interesting conundrum. Like here, we have that data, but the tool has to be taught whether this is actually a problem or not. And unless you go into that tool and teach it explicitly, like, hey, you should see these and these and these fields, which is, by the way, very fragile, because if you add a 4th field, then your test is going to fail, your scan is going to fail, and you have to go and fix that one as well. And that is something that we definitely face as a challenge. And one of the solutions I've been talking about, and this is not going to be news to you, by the way, but I swear, hand to God, that I've been saying this before I started talking to Colin and you and friends at 42 Crunch. API contracts are kind of a solution here, because an API contract and a Swagger spec or Open API spec these days basically explicitly lists what your API is supposed to do, what it accepts. So that's a countermeasure against 6, and what it spits out, what it returns, that's against number 3, and that you can feed that into a tool as well. There are security testing tools that take API contracts as input, and they can run requests against your API and be like, hold on, your contract says you return 3 fields and the API returns 4 fields or different fields. Like, something is wrong. You figure out what it is, but at least we now know something is wrong. So yeah, I'm a big fan of contracts.
Yeah, I think that, I mean, that, to me, that's absolutely the advantage of the design first, is that it makes people think about, what does that data contract look like? What is the sensitivity of the data that they're exposing? And it forces that upfront security design. So yeah, but absolutely
yeah,
right.
That's a theory. In practice, I've been working with a startup, and in practice, we write like a spec and then add a field to do. Let's see what else we need here, because you don't always know how things are going to turn out, especially when it's a very underdefined system and it's in active development. But yeah, keeping these things up to date is absolutely crucial. But the contract is an awesome communication tool as well, because you have usually front-end people, back-end people, or API people, and you can define a contract and tell the front-enders, like, call this in that way, and we'll make sure it works when we put things together. And that actually works really well in practice. So it's all benefits from contracts, except for the writing YAML part. That's the only downside here. But
I'm just going to take the question now from Adrian, and to the attendees, please do start firing up questions. We're going to, we're halfway through. We'll start picking off the questions as they come in. And the question is around DAST. So, how well, and I think you partly answered this, tools like Burp and Zap, how well can they be used to find those vulnerabilities? My take on that is that, they absolutely can import specs, but they don't have that full context, right? They can't enforce the data contract, and often they're going to require pretty specialist levels of pen tester skills to be able to manipulate the APIs. So the tools are useful, but I think particularly around DAST, you're going to be prone to quite a lot of false negatives. So don't overly rely on DAST for your API testing.
Yeah, that's a pretty solid response. I'm very happy you answered that, because I usually use these tools in demos and things like that. If we have time in the next sessions, we might run 1 or 2 like that. But that's manual effort. So I'm not very, very up to date on the whole automation thing. It's a big market, of course, and of course, you guys are running a lot of tools on top of API security contracts as well. But yeah, this is definitely something that's getting more and more attention and is becoming more and more important. So yeah, absolutely.
Yeah, and I do see the two questions around that have just come in about contract security testing. You know, the advantage, as Philippe has alluded to there, you know, it's a positive security model, and I think that's one of the big advantages with APIs is you have that contract, you know exactly what the inputs and outputs are, whereas with a web app, and it's very hard to know, you know, what should the web app be doing, how should it be behaving, whereas the API, you can absolutely, you know, enforce that through contract, and then you can enforce that through testing.
At least if you have a nice API. I mean, yeah. I can write you an API where you can simply not write a contract that makes sense. So
yeah,
but yeah, if you have a well-defined API, then absolutely a contract is going to be clear-cut and very concise. Like, this is what it does, no question about it. Absolutely.
Yeah, so to the two people who've asked the question about that, we will share links. You know, obviously we've got other webinars that we can share, and we will follow up about you know, what contract testing of APIs looks like. So we'll just mark those as done.
I see a question about how to write contracts. So I would say Open API is definitely the de facto standard for writing these things today. That used to be Swagger, if I'm not mistaken, and it transformed into Open API 3. If correct me if I'm wrong there.
That is correct.
Yeah, and the best piece of advice I can give you is try to find a way to add your contracts directly to your endpoints. So having a separate spec is nice because you have everything at one place, but it's very, very challenging to make sure that that's up to date, especially if you're actively developing an API or if the API is prone to changes. Then, well, at least in development timeline, it's going to be easier to keep things up to date if you put them straight with the code. So you have everything at once. You update the code, you modify the contract. Keeping it separately, or you can extract it later, of course, with tools, but keeping it as a separate file is a bit more challenging to keep things up to date.
Yeah, and I don't think there's much to choose between, you know, if you're going to work with Swagger or Open API 3, there's fantastic tools, you know, online that'll convert anything to anything else in whatever format. If you want to be in JSON or you a YAML guy, that's all easily done. Philippe, let's go over to some of your case studies. You've put together a couple of case studies for us on, you know, where things go wrong. Let's have a look at a few of those.
Yeah, sure. Interestingly enough, the audience said, like, yeah, authentication issues are quite common. So the first one I actually have is about authentication issues, and it highlights the issue I've been talking about, where we separate the client from the API, and we kind of create issues that way. So this is a study from last year from healthcare apps in the UK. So not unsensitive apps. I mean, healthcare, these apps have sensitive data by design. And it turns out that they tested about 30 popular applications, and you can find the full report at the URL, by the way, and 77% had hard-coded API keys.
Yep.
I mean, usernames, passwords, hard-coded in applications. And that is a perfect example of how problematic it becomes if you take what used to be a monolithic backend application, like, yeah, you can put whatever you want in the code. Nobody's ever going to read the code in normal circumstances, versus let's pull it apart and we have a client app now, which can be a mobile app or a JavaScript frontend app, and we have that API. And all of a sudden, credentials and API keys now live in that frontend app, and somebody can easily extract them. I mean, there's this very sophisticated tool called Strings on Linux, which basically prints out every human readable string in a binary file, and you can just go look at, like, yeah, that looks like an API key. Or you can look at the network traffic using a proxy tool like Burp, and you'll see, like, this key goes on every request. Like, what if we copy paste it on a malicious request, and boom, there we go. I think Brewdog had that problem a couple of months ago, and of course, I learned about it from your newsletter. So yeah, that's an awesome source.
I mean, that's one of the things that having been, you know, writing and curating that newsletter for 5 months, is a lot of the worst issues, a lot of the worst breaches are actually down to relatively basic housekeeping. It's not very advanced attacks on a multiple stage, you know, OAuth 2 attack or any of that. It's often very basic things. The Brewdog one, hard-coded credentials for the 3 different environments. It's easy to detect.
Yeah. This result from the study, to be honest, this surprised me, because this shows us what kind of a long road we have to go. If 70% of apps have hard-coded API keys, I imagine in my world I live in, that's the first thing you learn when you're following a mobile development course and the topic security comes to mind. Like, never, ever, ever put anything that you don't want exposed in a client-side binary or bundle if it's JavaScript or whatever. And here we are doing exactly that. The study checked other things, by the way. They also checked API endpoints, because that's kind of what we're here to talk about. And they found that at the API endpoints that they looked at, 100% had BOLA attacks. 100%. Every single API had authorization problems. And that is unfortunately the world we live in. It's again that decoupling, the fact that your endpoints are now fully exposed means you have to adopt a different mindset when thinking about security. And one of the things I really focus about when I start talking about authorization and APIs, the first thing I tell people is forget about the client. The client plays absolutely zero role in your API security setup or API security behavior. You look at the API itself, at all the endpoints you expose, and that's what an attacker is going to go for. The endpoints you expose, and whatever you think that the client does doesn't matter. I mean, who cares that the client hides features from the user? Guess what? The attacker is not going to rely on the client application. And that's something really important. And that also means that the people testing your clients, if they test the front end of a traditional app, they could also check for some security stuff. But now testing a separate client, like a client application, a mobile app or a front end app, you cannot put security into that process, because it doesn't matter at that point. It only matters on the API side, not on the client side.
I think you've got the Bumble example is next. And I think that was a typical case of where.
Yeah, these are common. Absolutely. You've been looking at my slides, Colin. So Bumble, there's actually, throughout my courses, I use a whole bunch of dating apps, all anecdotal, by the way, no experience myself, in case my wife is in the audience. But the Bumble app, they enforced a whole bunch of restrictions on the client, like silly things, like paid features, like, oh, you can't access this feature unless you're a paid user. Well, they only had checked that in the client based on your authentication data. They never checked that on the API. So if you look under the hood, you could start sending requests to these premium endpoints, and the API would just honor that request and do whatever you asked it to do. But also other things like implementing rate limiting of how much you can swipe left or right, if that's something Bumble does, because I honestly don't know. But rate limits on certain API features were implemented on the client. And that's another example of why the client doesn't matter. If you give this to an engineer, a Q&A engineer, and they're going to test the thing out of the client, and oh yeah, I can only vote of people 5 times. Good, check, we have that. But somebody getting those requests can just open it up, replay that in Burp or in Zap or whatever you want to use, and send these requests over and over and over again. And we have, again, a vulnerability. And if I'm not mistaken, that was listed in the OWASP top 10 on, let me skip back, on number 4, lack of resources and rate limiting. And that's really, really common. And that can result in authentication problems. 4 can lead to 2. If that endpoint is accepting a TOTP code, then 6 digits, I can easily brute force those 6 digits until I find the correct one. Plenty of cases that evolve around that as well.
Okay. Do you want to cover the GitLab? You've got another example, and then maybe talk about the Netflix, and then we go on to developers and because we're going to have a lot of developers on this call, and let's talk about what we do to get them engaged.
Yeah, the GitLab example is not really that interesting. The main point here is more of the same, as in, I can keep going about this. I actually keep all of these cases. So I save up your newsletters and I process them and I put them in my notes, like, okay, this type of vulnerability, incident, and the list just keeps on growing. So again, we had a client enforcing certain restrictions, but the API didn't implement those checks. So in this case, the guest user would be able to access merge requests that they shouldn't be able to access anymore, just because the API never enforced authorization properly. And if you're ever looking for cases like this, a good source, by the way, are these bug bounty reports on HackerOne, on Bugrat, on Integrity, because they actually have a lot of real world cases with useful information in there. So yeah, it's, I would say, history repeating, but it's not really that old. These cases, it's a lot of the same vulnerabilities, which is why authorization is #1 in the API security top 10, and the regular top 10 for that matter.
Sure. So let's just close off on what do we do about this? You know, how do we get developers engaged? So at a couple of levels, from an organization, what can organizations do to, you know, drive improvement and an awareness of API security? And then particularly around where can developers go to learn more? Right, I took a quote from your website, and you've said, every time I teach these topics, I get a ton of questions, which show how hard it is to make decisions in this space. So how do we, let's start with the developer. What can an individual do? Somebody tasked with developing APIs, what do you recommend? Quick wins for them.
I don't want to start with developers. I want to start higher up. I want to talk about companies first. And that's actually something I do in my introductions. Companies need to provide developers and architects and so on with the resources to do security. Because security it's always going to be a cost until something happens. It's always going to be like, yeah, what do we get for spending money on security? Nothing. Just it's like you're looking for a negative result. I mean, something doesn't happen, that's a good thing. So yeah, spend money on security. And that means companies have to provide developers with time to spend learning about security, because if you never have the chance to learn, then you're not going to be able to improve. Time to actually build features out more securely, which sometimes takes a bit longer because it takes a good design, and there's going to be some other things that you're going to have to pull in to make that work, and so on and so on. But in the end, that's really going to work well if you provide those resources. And on a side note, one of the cool things I see happening in the last years is that I get a lot of requests from startups. Startup companies coming to me like, yeah, we're going to launch this product. We're not there yet, but we need to talk about security. And they want to get this right from the start. And I'm more than happy to work in projects like that, because you can have some real impact there. Now, what can developers do? Well, developers have to have a solid security awareness. That's kind of a mandatory thing, just like a developer has to have some solid performance background. I mean, you have to know at least how to write code that performs well. And the same goes for security, I would say, and for accessibility and all of these things. You have to have some notions to realize when you're doing something with security consequences, so you can go ask the right people how to do them correctly. I'm not advocating to make every developer security expert, because to be honest, I struggle keeping up with how fast things change in the security landscape, and I'm a security expert. So what I expect the developer to do is to realize, like, hold on, this is probably something security sensitive, and go ask the security team or the security champion in your team or whoever responsible or more responsible for security, like, can you take a look at this? Is this the right way of doing that? And the security team can be like, oh yeah, that's solid, or no, you want to probably do this. So that's what developers can do, and they should push for that. They should tell their managers, like, yeah, man, we need security training. I might be of help there, but there's plenty of workshops and resources to go to, and you need at least that basic awareness of what it means to build secure software.
Yeah.
And then the third part of the puzzle are security teams. And that kind of brings us to the Netflix story, which is a good story, by the way, not a negative story. And that story, I highly recommend to read this blog post from Netflix. It's really, really good. Medium says it's an 11-minute read. I'm not sure about that, but it's a bit of a read, but it's going to be worth it. And the story starts off with Netflix taking security seriously. They have a security team, and they're like, we have to build secure applications. Like, how do we do that? Oh, here's a couple of checklists with a few hundred items. Solid. If you do this, we have secure software. But the security team doesn't build anything. So they take that checklist, they go to a development team, and they're like, yeah, do you have some time to run over the security checklist? And they look at it and they're like, not really. Come back next week. And they had a really hard time getting people to actually take the time to do security, because it's hard to find time to do all of that. And the way they transformed that, I'm going to kind of spoil the story here, but go read it anyway. But the way they solved that is like, what if we help developers do their job better? What if we give them a tool that sets up a product environment so they can basically be up and running with building a new app in 10 minutes? That's literally what they did, 10 minutes to set up the whole infrastructure and start the code repos and scaffold everything out. And they added security in that process. They're like, oh yeah, and while we're doing that, we can make this step secure, and we'll add authentication with our authentication service by default, and we'll provide this and we'll provide that. And they basically reduce those huge checklists to run this command and we're done. Security is in place, at least authentication authorization is in place, and you are up and running as fast as possible. And that's something that really struck me a bit when I read that, because I was doing a keynote a week after, I think, last year. And that kind of gave me inspiration on a bunch of other things as well. Like, yeah, that was kind of the missing piece of the puzzle, because I've been working on React a lot last year and React security. And I ended up with this massive list of recommendations, like, don't do this, make sure you do that, don't do this and that and that. And eventually I thought, like, this is never going to work, because we can't expect every React developer to know these 20-something guidelines and never mess up. And one of the solutions I kind of thought of and checked with a couple of developers, and they're like, oh yeah, that will work, is by providing a developer with a component that does exactly what they needed to do by adding, while adding security in the meantime. And you can look up that session online. It's from the OWASP anniversary event, the keynote, where I discuss this in a bit more detail. But the takeaway here from this story is basically, if you're in a security team, when you want developers to do security better, make sure you help them achieve their goals while adding security in the meantime. Don't make security this add-on, this extra thing that needs to be done. Make it something that's part of the process from the get-go. And that seems to result in awesome advantages, awesome progress, basically.
Yeah, the Netflix article is great. I've put the link in the chat for people to go and have a look at that.
Yeah.
For me,
will we see that in a newsletter this week, Colin? Will it be there?
I would. I think we could. Maybe not this week, but definitely next week.
I'm putting you on the spot now.
No,
so
it's getting busy again in the new year. I think that the one thing that jumped out at me there was that term they use, paved roads, build paved roads, where don't get in the way of the developers. And then the kind of soundbite from that was hitch the security wagon to developer productivity. Or if you enable and make developers productive, they're going to come. They're going to come to the water. Given we've only got a couple of minutes left, let's have a look at questions that we haven't on. Now's a really good time to fire in questions. Let's have a look at Adrian's question around shift left security. What are the best practices tools that a developer should use to check that the API they're developing is safe? There's an easy answer for me to answer there. 42Crunch has a continuous audit tool, and there's a VS Code extension in the marketplace with several 100,000 downloads that will continuously assess your open API spec as you write that, your definition, as you write that, with the guidance and help on how to fix that. There are other tools. There's things like if you're developing your specs, get Stoplight, use Stoplight. That does a great job of helping those developers code up those APIs. So hopefully that, and Postman obviously is the other one to be using on that. So I'll mark that as answered. Hitesh has got a good question. This always comes up, is inventory. How do we, the problem is we've been developing APIs for ages. Everybody's got lots of APIs. The APIs are growing. And the problem we have of securing these APIs is we don't know what we have. All right, so what approaches do we have for inventory? I'll answer that first part. If you've got GitHub and if you've got kind of central code repos, it's quite easy to use tooling. Things like semgrep can grep through vast volumes of code looking for fingerprints of things that look like APIs, whether it be code bases or spec files. That's quite easy to do. And if you're looking for running instances, I think you're stuck with doing network or traffic analysis and trying to look for things that are looking like API requests. Philippe, I don't know if you've got any further insights. It's not an easy problem to solve.
No, absolutely not. To be honest, it's a bit further from my expertise because I focus on building secure APIs, not finding the insecure ones. But I do know this is a pretty hard problem to solve, and there's actually companies explicitly focusing on finding whatever you have online, because well, people regularly lose something somewhere and only discover it once it gets breached, even if they find it then. So yeah, honestly, I don't really have a good answer there. I can add more stuff to it. It's not just APIs these days, but we see a lot of problems coming from like dangling DNS records that are left over from something old. So it's really a fundamental problem to how we've gotten accustomed to deploying things, and especially in cloud environments, it's really hard to log this up. So it's definitely something for which I expect a lot of things to move in the coming years, because this is getting more significant as these APIs get older. Unfortunately, I don't have a good answer though.
No. Okay. Amal's got a question on DevSecOps and why we're not able to fix security issues. So why are we not able to? I think we're definitely making progress as an industry. I think when I just think about 10 years ago, hardly anybody was talking about software security. And people were producing very, very vulnerable code. If you consider today how much more code we're producing and how much relatively, the code is definitely more secure. We're definitely making progress on this.
Yeah,
Philippe, I think we are getting better. I think web applications, particularly, it's a much more mature technology. There's a lot more awareness. 10 years ago, if you'd spoken to a developer about SQL injection, they would have blanked. They wouldn't have known what you're talking about. Whereas nowadays, most people have an awareness of what an injection attack is.
Yeah, maybe that is indeed true, but I think on the one hand, we are getting better. On the one hand, we have a lot of developers much more experienced with security, but on the other hand, we have so much more APIs than we had 10 years ago. And I honestly not sure which one is growing faster, the experience with security or the number of APIs we have there built by developers with maybe not enough experience with security. And add to that the fact that developers are getting more and more responsibilities, like putting the operations part into the development part. That raises a whole new host of issues. Like all of a sudden, we're dealing with host-based security things and container security and all of those things. And it's just a really fast-moving landscape. And I think it's really hard to, it's getting increasingly harder to come up with a set of solid security guidelines that you can follow. Back in the day, it was like,
yeah,
here's a bunch of secure coding guidelines, just don't do these things and we're probably good. And now it's like, here's a whole bunch of issues, and some of them are easy to solve. Some of them are like require 3 days of studying God knows what from AWS before you can figure out whether something is secure. And the landscape, from personal experience, I can definitely say the landscape has gotten much more complicated. And that's the downside of this great evolution. So I would say.
So with just a moment or two to go, he's put up further reading, further information. Obviously, there's various ways to reach out to us. Definitely get a hold of the API security newsletter, and feel free to ask me questions on there. Closing question for you, Philippe. Are you a pragmatist? Are you an optimist or pessimist? If you're talking about, so I'm going to say that I think I'm probably, on the balance of things, I'm quite optimistic, right? I think that we have the attack surface is getting bigger, the technologies are getting more complex. It feels like intuitively that the problems are going to get worse. I think that we have great communities, we've got top experts in the field, we've got a growing knowledge base. We've got automation. The tools are getting better, right? The tools that we have now to be able to test our software are vastly improved. than they were a decade ago. So I'm going to definitely put my hand up and say I'm cautiously optimistic. Where do you sit on that spectrum?
Yeah, my company is called Pragmatic Web Security. So I'm mostly pragmatic about these things, as in, how do I say this? A lot of people often very much dislike the current situation and aim for this utopian world where a lot of technologies turn out to be more secure than what we have now, and that would be awesome to go there. I just don't see that happening overnight, because people are using the tools we are today. People are building applications in the technologies we have today, and we have to focus on securing them. I have to be an optimist, by the way, because otherwise I wouldn't be very good at my job. Yeah. A pessimistic security trainer is, I wouldn't say very useful. Like, yeah, here's some problems and we're never going to be able to solve them anyway, so let's have a beer instead of teaching security. Like, no, that wouldn't work well. So yes, I am optimistic, but I don't see individual developers solving security necessarily. I see a cultural shift solving this, and that cultural shift consists of developer awareness on the one hand, and better tool support based on API contracts and stuff like that on the other hand, to actually solve a couple of these things fundamentally instead of one by one.
Fantastic. Hugh, do you have any closing comments? Because otherwise I think we'll call this to close, and thank everybody for the attendance. Great to see the questions coming in. Great to see so many people joining in. Thank you for the feedback and comments. Thank you, Philippe, for your input. It was, for me, fantastic to have you on, and really looking forward to the next session on February 17th, where we're going to be talking about Auth-N and Auth-Z. So that should be good. Yes. And then the follow-up in March the 24th on everything else.
Yeah, I have a closing comment about that. So this one was the introduction, like a back and forth of how things go. In the next sessions, I'll definitely be more technical. We'll discuss, well, it's only an hour, so we're not going to go into super detail, but we'll discuss the OWASP API security top 10 issues one by one mostly. And I'm going to give some examples and definitely focus on defenses and solutions. Absolutely. Hope to see you there, by the way.
Yep, very good. Look forward to it. And with that, thank you for your attendance, and I will close the session. Thank you very much.